to talk a bit more about comparing two methods. We are going to the hamburger menu, and we are going to open. We are going to work with a data set that was taken from the Journal of Chemical Education. So we go to browser, and we are selecting the spreadsheet Fluoride. Oh, we have a manuscript where the fluoride concentration was determined in black tea, green tea, toothpaste, mouthwash, groundwater. The authors have determined the fluoride concentration using a colorimetric assay. Just was done in the last example of this playlist, is a colorimetric assay, and they used a smartphone instead, spectrophotometer. The question that we have to answer was the two methods equivalent? I can use a smartphone to determine the fluoride concentration with the same reliability that I can do it using a spectrophotometer. Well, the first thing that we do is go to exploration descriptives. We select your variables, and we are going to do some basic statistics. You can see that it was done in 8 observations. We have the median, the mean, the standard deviations. We can do the Shapiro-Wilk test to see if the data was normally distributed. We also had a lot other plots. For example, I have a box plot in here. The box plot shows that there is no outlier results. Outlier results are results that is very far from the rest of the population. I can do histograms to see how your distribution was. We don't have nothing that remember a normal distribution, but it is very short data. It's just 8 numbers. Looking to the descriptive statistics, we can see that both methods provide close numerical results, but both methods were equivalent, were statistically equivalent. We are going to see this now. We are going to t-test. We are going to paired sample t-test, and we select required variables. We have the proposed method and the reference method. We can do some checks before to do the statistical tests. We can go, for example, to Kiki plots and normality tests. We can see a deviation from normality. And the Shapiro-Wilk test, Anderson-Darling test said that the data was not normally distributed. So the best options for us in this circumstance are the Wilson-Ranked test, because your data was not normally distributed. We can do both the parametric and the non-parametric tests. And both tests said that the two methods provided equivalent results. Well, in this circumstance, when the values were very close, the values that you obtained using two methods and the values are very close, numerically close, you don't have a lot of trouble in using a parametric and a non-parametric test. Normally, the results are close, obtained with a parametric and a non-parametric tests. However, since your data was not normally distributed, we must use the Wilson-Rank test. We can, I like graphical plots because a plot provide you more information than just the p-value. We use the descriptive plots, and we can see that both methods provide very close results, and both methods have almost the same standard deviations. So we can say that the precision of the two methods is the same. Sorry, the accuracy of the two methods is almost the same, since the averages and the means were very close. And the standard deviations obtained using the two methods are very close, you can see for the bars. So we can conclude that both methods provide some precision and some accuracy. The methods are equivalent, and the standard deviation obtained with both methods are very close to. Well, to the next video of your playlist. This playlist was presented in a Journal of Chemical Education manuscript, and it was provided as a self-learning course that you can take by YouTube. I expect that you like. We have a lot of videos in this playlist, and you can contact me for any questions that you might have, or just write it in the comments of your videos.